So I don't see any new people jumping in, but I'll be watching that. I'm gonna start things off here. I got some stuff ready to go. So the goal today would be to just go over the basics of all the electrics involved in electric flying. So obviously it means we're not talking about any gas flow type stuff, and really more the electrical side of all that type of stuff. So we'll do more Zooms, obviously. I think we'll do every Saturday now for a little while. And we'll leave things like building planes and setting up planes and all that stuff for other ones, building and repairing, of course. But today we'll focus on just the electrical side of things and all the components and what they do. And so we have an idea of when we go to build a plane, what those parts capabilities are. So, so you should see my camera now. You guys all see that?
I see an oscilloscope or
Yes.
a PDR or something.
Yeah. Okay.
Yeah, I can see it.
So we'll cover this from the real root basics end, make sure we're all up to the same speed. And, the hopes are we know most of this stuff, but each of us takes away a nugget or two of new stuff that we didn't know before. So all electric planes, obviously, you have to have a battery, right? And a receiver of some sort. And then I have them together here. We'll have something to control the motor, in this case an ESC. And my motor, it's already connected to that. And then we're going to have things like servos to control our surfaces. And we might even have electric retracts for landing gear. So those would be the basic parts. If we were to build an electric RC plane right now, we would just need probably some more of these and the appropriate mix of stuff. So what I want to do right now is go through each of these components one at a time and talk about what they do and what their capabilities are. So let's take some away here. So when we're talking about batteries, anyone who's been in the hobby long enough now knows that they come in all shapes and sizes, obviously. And you don't have to fly for very long to start to acquire some of these things in all those shapes and sizes. But they come with a lot of numbers on them, don't they? What all these numbers mean. So let's start with some of the odd ones that we see sometimes. This one says 4S1P on it. This other one says 3S1P on it. And most of the time, you don't see that on batteries. These two I happen to have it on there. A lot of batteries don't even put it on, but we tend to see that a lot on the websites when we're buying batteries. And what that means is it's telling you the construction of the battery, how many cells are inside it, and whether they're in series or parallel. And that's why the S and the P. So a lot like the ubiquitous flashlight that we all have known for years, and I would stick two batteries in there. Well, those batteries are in series with each other. That means the minus of this battery goes to the plus of the battery, which connects to the minus of the next one to the plus of the next one. And they're in series. If they were parallel, they'd be like that and soldered there. And what I've noticed, I don't know about you, any of you guys, but when you go to buy batteries, you almost never see any ones that are two parallel or three parallel. For the most part, batteries are always one parallel set of cells. And I grabbed these batteries here because you can see the cells in these batteries. So these batteries, you can see the separation of the cells here. This one has clear sides. Some of these batteries, like Eternity, are all blue. Can't see anything in there. But we can actually see inside these that there's one cell right here, and then another cell, and another cell, and another cell. So we can even count the cells in the batteries without even looking at the label or any of the wires.
Hey, Chris,
Get in there. Yep.
is there an advantage to whether they're in parallel or series? The way they make up the
Well,
packs?
there is, and there's reasons for that, why you'd have, when you put batteries in parallel versus series. Paralleling, when two batteries are in parallel, you've combined the current capability of the batteries. You double the current capability. When you put two batteries in series, like in your flashlight, you double the voltage, but not the current. Does that make sense?
Yeah.
Okay. For the most part, and I'm today we're going to talk about all the mainstream, right down the middle of the road of electric RCs. There are certainly lots of cases we can talk about that are far off in either direction. But everything we're looking at today is all the pretty standard stuff that we would see on most planes at the an RC flying field. And that being said, most of the batteries, again, internally are just one set of cells in series. They're not two sets in parallel inside there. They could build them that way, but they obviously don't. I have a plane where it runs on two batteries, but those two batteries are wired in series inside the plane. As a matter of fact, this battery right here that I'm showing you, it says B1 on there because I label them so I keep track of them. And there's a B2 that goes with this one, and both those batteries are used in that plane. And this is a 4S battery, so that plane runs on 8S. So I plugged the two batteries in to make it be 8S. Can I answer your question? And what's going on inside this battery? So we talked about, I stick the batteries in my flashlight end to end, that connects them together. Well, that's what's going on in the end of this battery right here. They've done that for you inside there. The big leads are connected to the lowest cell and the top cell, but these balance leads are connected to all the ones in between. That makes sense? And so this 4S battery has 5 wires coming out. Well, that's because one wire's at the very bottom, the 0 volt. The next wire is at the junction of the first and second cell. Another wire at the junction of the second and third, wire at the third and fourth, and a wire at the top of the fourth. So 4-cell battery gives you a 5-wire balance plug and so on. So whenever you look at a balance plug and you want to know the cell count of the battery, it's going to be 1 minus the number of wires. Okay. So there's a lot we can talk about batteries. We can do a whole Zoom class on batteries, but I'll try to finish up by just talking about these other 2 numbers on here. So the other numbers on the battery, the C and the milliamp hours. So what's going on there? So all batteries have a C rating for them, but most batteries like AA batteries, our car battery, don't put the C rating on there because it's kind of irrelevant to you. But to us, using batteries like this in planes, it does matter. And the C is equal to, for any battery, 1 times its amp hour rating, and that's a C. So C is this number that was come up with for batteries as a way to know how to use a battery properly or healthily. So let's talk about this other number now, this 5,500 milliamp hour on this one, or 2,200. So that's kind of like the fuel gauge for the battery, how much capacity it has. Okay, so 2 batteries that are the same cell count but different milliamp hour, one has more, one has less than the other. And so I show these 2 batteries right here because sometimes the big number that's on there is not the same type of number as on the other one. So this one, they show 5,500 milliamp hours. This is 2.2, but in really small writing, they put 2,200 milliamp hour. So millis, the term millis, let's cover that, make sure anyone who's not familiar with it. So if I have something that's 1 amp, I could also have something that's 0.1 amp, another thing that's 0.01 amp, .001 amp, 0.0001 amp. And at some point, as the number gets smaller, it gets harder and harder to talk about it because I have to make sure I tell you the right number of zeros. So at some point, it's easier to take a number like this and say that that number right there is really 1 milliamp. Okay? So in the milli, this term milli just means we've moved the decimal point 3 places over. So that way we don't have to say a bunch of zeros. Okay? So battery makers, I don't know why, tend to like to put this big number on here, 5,500 milliamp hours. Probably looks more impressive than just saying 5.5 amp hour. Okay? However, this other number, C, the C rating, is referring to the amp hours of the battery. And 1 times that. Okay? So, to bring this full circle, what they're telling you is this battery here that's got a 45C rating and is 5,500 milliamp hours, they're saying that if you take 45 times 5.5 for the amp hours, you shouldn't pull more than 247 amps out of this battery at any given time. How are we doing? Does that make sense?
I missed that part. Can you say that again?
So the way to use this C rating on a battery, now let me back up and caveat one thing. Obviously, if you bought a plane all ready to go out of the box, all the stuff's been taken care of already. And that's all fine and dandy until you have to fix something or buy a new battery. And then it starts to come into question, well, what's the right thing to use for that? So the C rating on a battery is how fast you're allowed to take the power out of the battery. And this one here is 25 to 35. So I'll take this one right now. We'll talk about this one. So on the low end, it says 25C. Again, C is that measure of what's appropriate for using this battery, appropriate healthy use of the battery. And so at 25C times its amp hours, 2.2, drawing 55 amps out of this battery is fine. It's okay. But if I put this battery into a plane that's going to draw a lot more than that, that's not going to be good for the battery. It's going to get hot and it might get damaged. And again, if you've bought a plane ready to go with batteries and everything, they've already figured that out for you. Now, how do we know? How would I know how much current I'm pulling out of a battery? Well, you'd buy a device like this that you plug in line with the battery, and you'd run the plane motor up, and you'd see on here how much current's being drawn and power and voltage, and then we know what we're doing with the plane. But we fly these batteries, and they have all these numbers on there, so I felt today was a good time to talk about what some of these numbers mean and what they're for. Does that make sense?
Yeah, I have a question, Chris.
Yep. So
it sounds like there's a little bit of a range, like the out of the box scenario that I have is the 3-cell 2200, but it has a 30C, so it's in the middle of what you're showing.
Yep.
They don't show a range; it just says 30.
Yes.
But by and large, what you're saying is, within reason, I could fly my plane with that battery or one that says 35 probably and not cause a problem. I'm assuming there's also a component with the motor and how much or how little the motor can take.
Yep. Yep. So for instance, a good example would be, let's say I've been flying this battery on a plane and everything's all fine, but this battery wears out because I've flown the plane for a number of years and it's just getting tired. It's time to buy new batteries. Mm-hmm. I would want to buy a battery that's at least this C rating or more. It has to be the right cell count so that it's the right voltage.
Right.
Range. So the number of cells determines the voltage. And amp hours would determine my flight time. Okay, so the range on this one, the reason they put on here 25 to 35, that's kind of a roundabout way of them saying, and I can show you some other batteries if I dug them out here. It's a roundabout way of them saying you can pull 25 all the time, or like this one, 35 all the time. So you could be flying around for minutes, holding the throttle at a certain setting that's drawing about 35 C out of this battery. For this one, that would be 0.3 because it's a 300 milliamp. So if I did that, if I did 0.3 times 35, so if I was pulling about 10 amps out of this battery during minutes of flying, that's okay. But then what they're saying is that other number on there, why the range, this one says 70. That's their roundabout way of saying, well, if once in a while you give a lot of throttle and you draw a lot more, so 70, oops, 23, and you drew like 20 amps out of it, that's okay, but you can only do that for like, and you want to, usually the website has more information than the stick on the label. They'll typically say that's like 10 seconds at the most. So that's why the range of C ratings there. And we see that a lot of times on flying, don't we? Where if we're flying, we're gonna throttle up and maybe go full throttle as we take off and climb out, but then we're gonna back off. And so whatever plane you put this one in, it's okay to pull a lot more current out of it, but most of the time you gotta draw a lot less current.
Okay.
You know, again, if you've bought something prepackaged, then it's all figured out for you. But at some point, hopefully you're playing around and you're tinkering with stuff yourself, or you want to buy a better battery for your plane, maybe one that lasts longer. Any other questions? So these guys, so wrap up batteries by saying that obviously, how do we know how full a battery is or how low it is? So hopefully your charger is a decent charger, and most of them nowadays are. Your charger is going to take care of charging it up to the appropriate voltage, typically 4.2 volts per cell. So this one right now is showing 3.96, 98, and 99 for the 2 cells that are in it. So your charger is going to charge it up to about 4.2 per cell. And you're going to fly it down to about 3.7, 3.8 volts. And the typical way that's done is by a timer on your radio. So when you first fly a plane, you're going to fly it shorter time than you normally would in the end, and then measure the voltage and see, oh, I could have flown another 30 seconds or a minute. And as you learn the new plane that you're flying, or they tell you in the manual when you bought it, you'll come to learn that, say, 4 or 5, 6 minutes of flying, and by the time you land, the battery is down where you want it to be. So what happens is it starts out at 4.2 volts per cell, but as you're flying, it's going up and down, depending on your throttle. And in the end, you land at some voltage, and over the course of a minute or two, it bounces back up. So if you run over and check your plane right away when you land, you're going to get a reading here, but a minute later, it'll be about there. And you want to end up at around 3.7 or 3.8, and that's a much heated debate what voltage to end at, but those are reasonable numbers to start with. And you want to store your battery at about 3.85. That's the magic number. All your modern day chargers, when you go to the menu that is storage, will store it at 3.85.
I got a question on that.
Yep.
I have a Spectrum Smart. I mean, it's made it even less. You don't do really anything. You just tell it storage or discharge or charge.
Yep.
Is there any reason over the course of the winter? I have flown a few times, but is there any reason if you're going to use them every so often that you just always go down to storage mode? Or when would you ever really want to discharge it?
So you do, if you're not going to use your batteries for, I usually tell people a couple days, some people say a week. If you're not going to be using it, you want to put it at storage voltage. So you want to always keep your batteries at storage voltage.
Right, I've been doing that. I'm just curious. I've not ever put it into discharge because it seems like,
Yeah. Yeah, I know. So I think it depends on the charger, but you're talking about the menu option discharge versus storage.
yeah,
Yep. Yeah, I don't know. I think it depends. Discharge is only going to discharge the battery. It's not going to charge it up. So if I take a 3.7 volt per cell battery and put it on discharge, it's not going to do anything. Well, it depends on its setting. It depends on the setting I've told it to discharge to, but I would hope it's not much lower than that because that's probably not good for the battery. Whereas storage menu option on most chargers are going to do whatever it takes to get to 3.85, whether it's charging the battery up or discharging.
got it.
So that would be the primary difference I'd leave between those modes. Again, speaking generically about any charging that's out there.
Also, Chris, maybe we should mention that there's another magical number of 3.2, and that is the lowest that you should ever go on a cell.
Yeah.
For a LiPo.
Yep. So we probably should talk about LiPo safety while we're at it, then, shouldn't we? Huh?
Well, I'm just saying, if you set discharge and you haven't set like you said, a particular limit to where discharge is to, you better hope it's not below 3.2.
Yeah, the Spectrum ones are dummy proof, and I'm a dummy, and you don't do it. You just plug it in, and it knows how many cells. It pretty much takes a lot of you just choose what of the three things you want it to do. I've never chosen discharge because it seemed like you could store it for quite a while, and every once in a while I fired up a plane. So
yeah, yep, yeah, and being that that they've already pre-planned everything. You say storage mode, I want to be a storage voltage. I think it's going to go up or down and do a storage voltage, which I think is probably for you the best way to go.
Yes. Well, I think, and to your point, Al, when would a battery ever get below that? Well, if I flew the plane too long, either because I just wasn't paying attention, I don't have a timer. So a lot of modern radios, the basic radios like from Spectrum, the 6Es and those other ones with no display, don't have a timer function. So you're relying on either someone next to you with a stopwatch or a phone or something to help you keep an eye on it. Or you're having trouble with landing, so you're having to do numerous go-arounds. So, but all of those are just in case of you shouldn't be flying the plane up in the air much longer than the time for the battery to come down healthy. Yep. We've never had extra go-arounds, have we? Any other questions on batteries?
I guess I do have one because I've had a potential realization just yesterday on a LiPo for your
Radio.
DX, in this case a DX8E. I was using regular batteries and then I kept wearing them out, so I bought the LiPo thing, the whatever version.
Yeah.
Didn't notice in the instructions that you need to set this to know that you're now running that type of battery.
Yep.
And I ran it to where it just went out, and I plugged it in and charged it, and the little charger doesn't tell you much of anything. So I did that 2 times, and I thought, oh shit, maybe I've now screwed this battery up because I did. And I went in now and set it. When I plug it in, I'm just curious, I'm assuming other people have used those, and how do you know how long to plug this battery in, or can you screw? I assume it's the same issue. You don't want to overuse it, or how do you make sure you don't mess it up in this receiver or the transmitter?
On the lithium ion battery, different than lithium polymer, you don't have to worry about storing it at lower voltages. It's okay to keep it charged all the time. And my rule of thumb is whenever I'm not using my radio, it's plugged into the charger.
Oh.
Only because every time I want to grab the radio and go, I know it's fully charged.
So you can just leave that plugged in like a phone or whatever. It's not an issue.
Yep. And so this DX6 I've had, oh gosh, 6 years now. And the lithium ion in it is still doing fine.
Well,
I'll tell you this though,
Yeah,
I don't think you'll see it on here probably, but because it doesn't like the bright light. When you go into your setting on your Spectrum and you system settings and you change to tell it it's got a different kind of battery in it, it's going to change the alarm voltage at which it alarms at. And it's going to pick 6.4 volts
yep.
default. Change that to about 7 volts. And I'll tell you why, because I lost a really nice pylon racer plane to that. I had 2 different lithium-ion batteries at the time. I bought 2 packs accidentally. And one pack I had in one day, I'm flying around and my radio goes beep. And I'm like, ugh. And the plane just flies off into the cornfield and destroys itself. And it's because that lithium-ion pack, all lithium-ion packs have a little circuit board inside of them that's protecting them from overcharge and over discharge. And the way they protect the cells from over discharge is to turn off the output without any warning. I mean the lithium pack that's in there, it's a 2-cell pack, and it turns off the power coming out of the plug that's plugged into your radio. So your radio will shut down without warning. And I came home and I tested that pack because I have data loggers and stuff. And I put a load on it and I charged it a little bit, put a load on it and data logged it, and it shut off at like 6.6 volts. So I contacted Spectrum and let them know about that their packs are turning off at 6.6, but they default the warning at 6.4. So the warning doesn't come in time. So.
Okay. So you say you change it to 7 or 6.8 or something?
I would change it up to 6.8, 7, something higher.
Okay,
I
good to know.
picked 7.2 on mine. So,
Well, I've had this thing plugged in and it has a little graph. It tells you like where it is, and it's only halfway and it says 7.3.
yep, right.
And I'm wondering if I damaged the, if I messed it up or not, but I don't know that this is maybe this never goes fully. I haven't had this battery very long, so I don't know.
So when you charge that battery fully, leave it on overnight, how high does it get?
Oh, I haven't done it overnight, but it's sitting here right now and I'm watching it to see if it goes up while we're talking.
It takes 10 hours to charge the battery.
Okay.
It takes a long time. Yeah.
Okay.
Yeah. It should get up to mine go up to 8.3, 8.4, 8.3.
Yep, 8.4 is what I've hit, and it takes a long time.
That's fine. I just was worried that because it went till the screen just went black and I didn't realize, so I thought maybe I damaged it.
I would move it on overnight, charge it overnight, see how high you get.
Okay.
Lithium ions can take quite an abuse for differences in voltage ranges. So if you're at 7.3, I would assume you can charge it much higher.
Yeah, it'll go much higher. But you can shoot me a message, Al. Leave it on all night.
Okay.
Also, it only charges when your transmitter is off.
Okay, that's good to know.
If you have your radio on and you got it plugged in, it'll power the radio, but it won't charge the battery.
Well,
With the radio off, it will charge the battery.
okay, I just turned it off. Thank you.
Cool. Any other battery related stuff? Like I said, there's a lot more to talk about batteries, but we've covered a good basic stuff.
Is there such thing as a 6S battery?
Sure.
Is there any reason why I would want to use 3S in series or a 6?
What's the advantage of 2 3S's in series versus 1 6S?
Yeah.
I would think some of the issues would be size, just fitting it into your plane.
Okay.
Also flexibility.
Yeah.
If you have a 6S plane and you have lots of other 3S planes, you probably already own a lot of 3S batteries and you can just double them up and use it on the 6S plane.
Yeah.
All right.
Yeah, I know. Isn't it Gary's F-14? The compartment for the batteries is long and narrow. He has to stuff 2 in there in series. Even if you bought one big battery, it just wouldn't fit. It'd be the size of the fuselage itself. Yep. Good question. Okay, let's talk about receivers. So We're gonna need a receiver. Receiver is obviously receiving the signal from the radio. What I want to say about receivers is receivers have a limited voltage input range. You'll see it in the manual or online when you buy it. Most of the time, we don't think about that because it's usually compatible with the power that's powering it, and it's not an issue. But there are cases where if you're building stuff, you can be doing, I'll show you in a little bit here, you can be doing some things a little different and it would matter. But receivers come in lots of flavors and sizes. If you have any specific questions on receivers, you know, ask me or Al and we'll help you. You don't always have to buy Spectrums. I use a lot of these Lemon RX ones for my Spectrums.
I thought it said lemon. I was like, no, it can't be called lemon.
Yeah, they work really well. So, so we would need a receiver, obviously. And so receivers, like I said, come in all flavors and sizes. There's a Spectrum one. This one's got this other thing on it. That's called a satellite antenna. So if I were to unplug this and just bind up this receiver by itself, it only has these two antennas right here. But this extra thing right here gives it two more antennas. And the advantage of that, and this is in a lot of planes in our club. If you were to look inside people's planes, you'd see lots of these. The advantage of that is you've got this big thing in the middle of your plane, and the receiver, this receiver may be not very close to it, but still it's in there somewhere. And at some point in the flight, the battery's between you and this receiver, and it can block a lot of signal. So in the plane, having another set of antennas farther away inside the plane means you always have one set of antennas between your radio and the plane.
Can you attach that to any receiver?
What's that?
Can you attach that to any receiver?
Receivers have to have, you know, the compatible port for a satellite.
Okay.
But if you were building a plane that you knew was kind of tight and electronics are going to have to be close by the battery, you could choose to use a receiver that takes a satellite antenna so that you can put this a little farther away, and it's obviously a lot smaller.
Yeah.
So when you,
Yeah.
and you may have a plane, I mean, some stock foamy planes come with these in them. So if you see this in one of your planes, that's what it is. That's what it's there for, to give you a second set of antennas. Now, we can talk a lot more about antennas and what you do with them. I'll just say at this point, if you have one of these in your plane, you want them to be at 90 degrees to each other. That helps reception. And some receivers are that big. That is a 6-channel Spectrum compatible receiver. It weighs half a gram. You have to solder all the wires on yourself.
Okay.
I haven't used it yet.
You say that like it's a bad thing. Come on.
I have it ready to go. Okay, so as far as receivers go, like I said, they are very narrow voltage range. And the key thing is the voltage range they operate at is not equivalent to a 1S battery, and it's not equivalent to a 2S battery. So you really should never be powering a receiver directly from a LiPo. Okay? There's always going to be some other source of voltage for that receiver somewhere else in the plane. And for that, we get back to our, we need a motor to fly our plane and an ESC, electronic speed controller. Okay, but not all electronic speed controllers are the same. So what are the key things, important things about an ESC? Well, their voltage range. So this one here can do 5.6 volts to 26 volts. Just so happens if you run the numbers for 4.2 volts per cell of your LiPos, you'll get anywhere from a 1S to a 6S battery. So that one's good for 1S to 6S, and this one goes up to 8S, as it says on it. Also shows 34 volts. The other key thing that's going on inside these, both of these, is they have what's called a BEC, battery elimination circuit. Now, Al's been around long enough to appreciate that. I haven't been flying long enough, but I know what it is. So if you go back right out to when RC World was only primarily gas flow type flying, you still had a battery in there to run all the servos. But as electrics came about, and you had LiPo batteries and brushless motors and ESCs, they said, well, we can get rid of that other battery you've been using, because the battery you used in those days didn't have to be that big. It was only running servos and things.
Yep.
It was flying a motor. We can eliminate that battery, hence the battery elimination circuit, meaning take the flight battery that you're using for the motor, put a little power supply inside of here that makes 5 volts that runs your receiver, and hence runs all the servos. So what's going on is this ESC, and 99% of the ESCs you've been seeing out in the field have this BEC in here. I gotta put my glasses on. This one can do 3 amps and puts out 5 volts. Now the interesting thing is I said that receivers operate between about 4.8 and 6 volts. They're not 1S, they're not 2S. They're in the middle because they expect to get about 5 volts. And there's that 5 volts. So this lead that goes to your ESC, that is your throttle signal lead, it's not operating and using these 3 wires like the servos we're going to talk about. Instead of it needing 5 volts, it's providing the 5 volts. So this lead is putting out minus and 5 volts on the black and red, but taking in speed signal on the white. And he is going to power our receiver. Okay? How are we doing with that? Make some sense? So if we went back a number of years, this ESC, Al, that's an old one, isn't it, Al?
Yeah, you're getting there.
So this ESC doesn't mention anything on it about a BEC, a battery elimination circuit, because it does not have it in it. And that's why this other thing is hanging on here. This is a little power supply that's stealing power off the battery input, and it makes the necessary 5 volts to run all the receiver and servos. So this goes back, this is an older one. I got this from Sal's plane. So that's what was happening back in the day, was you had a BEC, but you had to provide a separate power supply to run all your electronics if you wanted to use the flight battery. But then the more modern ESCs, they put it inside there. It's built into it. Okay? How's that? All good?
Pretty good.
Okay.
I just should probably I can add on that you can see that there was like 3 amps or 5 amps of BEC coming out of those ESC controllers. And some of my planes have very big servos and they need a lot more current. So that separate little BEC that Chris just showed from that old ESC, basically they make 10, 20 amp BECs that I use on the bigger stuff.
Yep.
Just because you need enough current to drive those servos. And so that's just, there's ways of getting more current to your receivers and to your servos, because you got to remember you're feeding, all those servos are feeding that current right off that ESC, the receiver, I'm sorry, out the receiver. So
does that information come with the servos, the current drain?
the servos current drain, you could get it from that. The other thing is receivers, the Castle Creation receivers I'm getting now actually have capability of running 2S LiPos. So it can go up to the 8.4 volts of a fully charged 2S LiPo. But typically you'd have to check each one of those receivers that you're buying. And, you know, you're taking a chance if you go over 6 volts with a receiver, unless it's rated to do it.
And this one here says it's 5 amp BEC, but you'll notice it doesn't say a voltage because the Castle ESC, so this is an ESC, controls the motor, but puts out voltage to power all the electronics. These are programmable. You can change the voltage, and we'll talk about why sometimes we do that, just so you're aware of it. But generally, again, the middle of the road stuff we see at the field is all operating at 5 volts. Okay.
Yep, 5
And-
volts and 5 amps will run just about any plane you have.
Yeah.
Till you start getting into the giant scale type stuff. So
Yep. And that's,
Helicopters.
I use one of these in some of my planes. So this is a separate power supply that you solder onto the battery leads, not the battery itself, but the leads coming in, and it's adjustable to 5 or 6 volts. So sometimes having a little more voltage helps, and we'll talk about that. But again, the middle of the road is what I'm putting out here, which is a BEC built into the ESC. Okay. So speaking of servos, our little workhorses. So servos obviously are doing the bulk of the work on our planes, aren't they? I'm going to power up now because I want to show you some things here. So what could go wrong now? Oh, on ESCs, so most most receivers give you a little symbol on there somewhere to show you how to connect. And they give you a minus, a plus, and a little pulse thing. So sometimes it can be tricky determining, well, do they mean when I'm looking at it like this or when I'm looking at it like that? But generally speaking, the minus is always farthest away on the circuit board. So this case here, the minus is the bottom row, plus is middle, signal's top. So I've got the white ones here, black ones there. As we were looking at, Alan and I were looking at the other day, that some receivers have double rows and they flip them from each other. They're opposite. So if you plug something
And the
in
plugs
upside
don't-
down, it generally doesn't do any harm. And because the designers of that 3-wire plug were smart enough to put the power in the middle. So no matter which way you plug it in, it doesn't do any damage. Okay. So,
I didn't know we were going to get a demo, Chris. Wow.
oh
Okay.
yeah, I know, huh? Crazy stuff, isn't it? So what we'll do is we'll take a look at, I thought we'd take a look at a couple things. You already segued nicely for me because I'm going to show you what happens, what makes things go awry here a little bit sometimes. So,
I can't say I've ever looked on a scope while I'm actually plugging
Yeah.
stuff in and burning things down. I'm not even starting things up.
so I have control over this servo right now. I don't know how much of a lag the video is. It lags on my end anyway. So I have control over it. And if you see on the scope, there's a series of pulses and the width is changing. And I'm going to zoom in on it so you can see it even better. So what your receiver puts out is a series of pulses. And what's changing is the width of the pulse. So as I change this guy, double that even more. Okay, so as I wiggle this, you should be able to see everything now. So we're going to see the pulse get shorter and the pulse get longer. And all our receivers, so like I said, the middle of the road we're talking about is 99% of what's out there. And what's happening is your receiver puts out what's called a PWM, pulse width modulated signal. And so the width of that pulse varies with where you put the stick. Okay, and it's varying between 1 millisecond and 2 milliseconds. So that's it. Everything we're doing, it relies on the interpretation of a pulse that's either 1 millisecond wide or 2 milliseconds wide, which is kind of crazy that our hobby was using this a long, long time ago and it just has stuck there and it stays there. So it's pretty incredible that this little device that we buy for a few dollars can properly interpret that signal and position this thing where we want it to be with the accuracy that it does. So a good question would be, how does it do that? So without getting too in deep, what's going on inside a servo? And the reason to show you this is so we can talk about what's different between an analog and a digital servo. So what's going on in here, if we took one apart, and you should do that sometime, take one apart. If you got an old one that you don't care about anymore, just take it apart and look inside. But there's a motor driving a gear, which goes through a series of reductions to drive the final output shaft and gear, okay? So if you took one apart and looked at what really is in there, there's more gears than this actually. This motor does a lot of turns to just move that output shaft 30 degrees. But the output shaft can only go so far. It's not going to go much more. You can buy ones that do like 180, but our typical servo goes plus or minus 30 degrees roughly. Okay. And as it does that, it moves this potentiometer that's connected to it. So for argument's sake, let's just say the potentiometer puts out a signal between 0 and 3 volts. Okay. Doesn't matter what it really does. But your control signal comes in, that pulse we just looked at on the scope comes in as the pulse. And this device inside there has to convert that pulse to a voltage. And so right now, my thing's sitting here at the stick neutral. So let's say my thing's putting out 1.5 volts. This part of the circuit moves this motor so that the voltage from the potentiometer is 1.5. When the two voltages match, the motor's turned off and the servo just sits there. Okay, but if I move the stick, the pulse changes. It produces, say, 2 volts. The circuit spins the motor until the potentiometer makes 2 volts. And then the servo is in its new position. That makes sense? It's no different than your cruise control on your car. You set cruise control to 70 miles an hour, it adjusts the engine and maintains 70. When the speed gets down to 68, it'll give a little more accelerator. Speed gets up to 71, it backs off and it holds it right there. So it's just looking at what the real number is and comparing to what you want and sets it. So the question that comes up a lot is the difference between, if you've heard, there's analog servos and digital servos. So this servo is a digital servo, but yet the one I have on there is an analog servo. I can plug them both into that receiver. They both get the same pulses going into them. So why do they call this one a digital servo? So because a lot of people think that a digital servo needs to have some different information coming in on this cable, but it's not. What's different is this circuit right here that converts the pulse, does the comparison of the position of the shaft and drives the motor. That circuit is digital. Okay. And how does that matter to us? Well, analog has some drawbacks and some advantages. It doesn't draw as much power, but it's going to be a little slower, and it's not always going to bring the arm exactly back to where you want it necessarily. And the reason is, to do that, they'd have to make that circuit be more aggressive to get that arm to come back to position exactly. And if they did, what would happen is then it would sit there and jitter. It would get into it would be too aggressive and it would not hold still anymore. So an analog servo has to be give up a little bit of centering to work. Whereas a digital servo, because it's digital and it's code, it's someone's written software, they can be more aggressive right up to the point where they get to position, then stop and hold it there. But a digital servo is going to draw more power, okay? So that's the trade-off of the two, and the fact and why some servos are called analog and some servos are called digital, but they're both take the same signal from the receiver, okay? That's as deep as we're going to get technically today, so you can take a deep breath now. So
Good explanation, Chris.
all you guys have, I would assume everybody now has had to bind their radio at least once, probably. And on a Spectrum, when you bind your radio, she says, binding DSMX 22 milliseconds. Yeah, so for those of us who've bound enough, so when she says 22 milliseconds, what is she talking about? Well, she's talking about this right here, the time between each pulse, 22 milliseconds. So I said this pulse can be anywhere from 1 to 2 milliseconds long, but the time between the start of each is 22 milliseconds. Now, I'll tell you this only because, and I know Kumar probably knows this because of heli stuff. If we want things to respond faster, we got to send this signal more often. So the heli world, they run 11 milliseconds on the radio. But if I turn, I did this earlier, I'm not going to do it right now because it takes 5 minutes. If I switch this radio model I have right now and this receiver to be on 11 milliseconds, then what we'd see on the screen would, I'll cheat, it would look like that. It would just be twice as often. Okay. But this analog servo can't keep up with that. It would start going, oh, because it never has a chance to finish dealing with one pulse before the next one comes in. The digital servo can handle that though. And it needs it to keep up with it. Okay, so all that to say, that's why there's digital servos and analog servos and what the difference are. How we doing? Any questions?
I got a question.
Yeah.
As you know, and again, thank you for helping me last weekend. I ordered one of these kits. I have a plane I bought, it's all made, but my son and I were putting together a kit and it comes with 4 servos and the ESC and all that. And there's a round thing, a long one, a square. There's like multiple other doodads. And I guess I'm just curious, what would you use besides the little arm? Everything I have is just what you showed. What are these other shapes typically used for?
Al, go for it.
Basically, as you're putting your plane together, you may decide you want better throw, or you might not have room, so you want a smaller arm. So the arm length differences basically come down to a manufacturer of a plane will ask you to deflect your surfaces, like 40 degrees, 20 degrees, whatever. And sometimes you need a longer arm in order to achieve that. The circle ones, again, I've never used a circle one, and I assume it's pretty much the same situation, where you're gonna be like maybe a push-pull type of situation, and
Yeah,
like for a rudder or something,
Yeah.
and you're gonna
there's
put
2 control arms. Yeah, same time. Yeah.
same timing. Yeah. So basically, it's just an option. Me being a 3D, all hell bent, give me everything I can get. I'll put the biggest arm I can on it. And many times I never put any of those arms on. I buy longer ones. So my servos for my giant scale airplanes, they come in 1.5 inch. I buy 2s, 3s, depending on how much extreme flying I want to do.
Gotcha.
Does that cut down the torque?
Yes.
Cut down the torque. Basically, you're using more torque. You may run out of torque because of the deflection of your surfaces. And wherever you put the position on the arm will determine how much torque you're going to be gaining or losing.
So that's a good segue. I wanted to show, I skipped over this. So a typical servo, so this is Hobby King, a digital servo here. And typical servo voltage is somewhere between 4.8 and 6 volts. And I picked this one because this is common. You'll see 4.8 and 6. And at 4.8, it's about 300 milliamps, and at 6, it's 400 milliamps. And they give you how fast it'll go for each of those voltages, and they give you the torque for each voltage. Now, I'll tell you this, though. I've done a lot of testing with servos, both at home and for some work stuff. It's a moving number, it's a variable number. So to give it a number is difficult. So these are approximations. They're not hard and fast numbers. So if you took this servo and made it work harder by putting a longer arm on it like Al does, you would probably get more current than 400 amps going into that servo. So, but those are good general starting numbers. Now, that 4.8 volts, that's important because when the voltage to the servo starts to get much lower, the servo is going to stop working. It'll lose a lot more torque, and it'll have a lot more trouble. So
Does that also cause jittering when the voltage gets too low?
it can. And let me show you something. Good segue. So the jittering can come from lots of things. A lot of times it is related to voltage being low, and the reason can be many things. Bad connections, too long a wire. And so along that line, I plugged in that digital servo, the big digital servo I have, because it draws a lot more power. And I changed my scope now that we're no longer looking at the signal anymore. We're looking at the voltage going to the servo. And if I wiggle it, you guys should be able to see if I make it move, there's a bunch of noise happening on that line. However, this other line I put on here is 4.8 volts. And if we look, the noise never gets below 4.8. And lo and behold, the servo is pretty happy. It's not doing anything funky, okay? But I have a long mess of servo wire here ready to go. And if you give me just a moment with my old man glasses, I take, now unfortunately, I don't have any long servo wire that's small gauge, because all the long stuff I have, I bought heavy gauge because I know about the problem I'm going to show you. So I've strung together 10 feet of this stuff just now. Okay. So now, notice those pulses are getting below the 4.8 volt line when I wiggle the servo. Yeah. So if this were not this wire I have right here is really heavy gauge, strong wire, it reduces the voltage drop at the servo. But you can see already how I was able to get this thing to start to get below its minimum voltage. And that's what will happen is either by using too light a gauge of wire, and I don't know about you guys, but if you notice on some of these servos, like this little cheap one I was showing you first, the wire in here, this is tiny little wire on this little servo here. And you can buy servo extensions that still use this little tiny wire. But the stuff I'm using for this demo is much heavier gauge. But that signal can really start to drop down to where the servo either can't move the control surface anymore or starts to jitter and do crazy things. And to answer your question, Steve, what I've experienced on some planes or helped other flyers with is the connection. You know, we're buying, these things don't cost much, and these connections cannot mate very well sometimes. And we've had lots of cases. I've had cases in just this past summer at the field, a couple cases where services are jittering, and we find inside here the connection is not making a very good connection, because a poor connection in a connector is going to create the same thing here, where now that it can't maintain voltage through that connection, and the voltage at the servo drops. And the servos, some servos, again, for work stuff I was doing, the servo kind of reboots or gets hung up and just stops working. So it's good to know either you're repairing a plane that you got that's all, you know, pre-built design for you, or you're designing your own plane. That can matter. Just getting good voltage to the servos.
Chris, the other thing was, means a lot of the digital servos have a hard time centering. And maybe that's what part of Steve's question is. I found that I have to actually go back and really be very close tolerances to centering the servos. Also, if they sit there loaded, I mean, if you have a control rod that's a little binding up a little bit more than, or something like that, I mean, it doesn't take much for a digital servo to chatter a little.
Yep.
And I mean, mine sit there and hum, which is a way, another version of, chattering.
Yeah.
Pretty much digital servos, if you can keep them just a little bit of chatter and not much, you've probably done about as best you can on that servo.
And that's actually pretty normal for a digital servo, where what the analog servo can't do, which is really drive the motor hard right to that precise precision point, a digital servo can and will. And it's okay. So for instance, you can't hear it, but if you look at the scope, if I just put a little pressure on this arm, we'll see the servo fighting against me.
Fight it, yeah.
Yeah. And it's sitting there making a little humming sound. And like, especially Al's planes, look at some of Al's stuff where he's got huge 3D control surfaces just sitting on the ground. The weight of the control surface, the elevator sitting there trying to fall down, is putting a little pressure on the servo, and the servo is going to sit there going, making noise. So, and that's perfectly fine for a digital servo, because that's what it's doing, is it's sensing the smallest little movement of the output shaft and turning on the motor to make it stay there.
So my rule of thumb on that is, if I can do a trim, one tick of my trim up or down, and the chatter goes away, I know I'm okay. Or like Chris said, if I can just lift a surface marginally, just barely giving it a little help, and if the chatter goes away, then I know I'm okay. That's as good as it's going to get. If it really starts to vibrate, then you got something else going on that you need to address.
Yeah, I have a feeling I'm gonna have somebody come over and give me some real specific help.
Yeah, I mean, so again, today we're looking at all the electrical side of all this stuff. We plan to do another Zooms covering now, okay, when you're building a plane, the right control horn to use on the servo, what holes to use on the servos and horns, wiring and linkage and play and the linkage and all that kind of stuff. So, but if you have any questions on that today, you can ask. It's fine. We just want to not try to cover too much stuff in one day. My list. So, as we saw on Hobby King's website, voltage affects torque and speed, and as we saw there, I can make the voltage drop down. So one solution for some plane designs is we'll just run everything at 6 volts, which is where we would either program the ESC that has programmable DEC in it, or we put that separate. So I run a plane that has one of these power supplies in it, just because my ESC puts out 5 volt on the DEC, but I want everything running at 6 volts to make sure my servos run as strong as possible. So that's the trick I'm playing on that plane. That's pretty common to do. So as far as what you're seeing, Steve, the interesting thing is you can have an intermittent connection. So let's say I have 4 or 5 servos plugged into this receiver. I can have a poor connection on servo 1 that's making servo 3 chatter. Or servo 3 could be doing really weird things, but it's a poor connection on another servo that's causing it. Because if there's a poor connection on here, every time I plug and unplug this thing, the servo puts a little load on the supply. And maybe this servo can handle that little dip, but the other servo can't. So even though we buy 5 servos, they're all the same make, model, part number, they're all built slightly different. Because it's amazing that we buy one of these things for $10, $15, $20 as it is, and what it does. But they're all going to be slightly different. So I've seen that on, a batch of servos, they're all slightly different from each other.
I had got this online. Basically, it's an inline capacitor.
Yeah.
I had heard that might try to solve that, but it didn't seem to do much.
Yeah. Well, it could, and again, if it's a poor connection issue or something else is going on, or let's think about this. I mean, you can wear servos out. If that potentiometer inside of here starts to come loose or have some noise in it, well, now the closed loop is trying to dial in on a moving target.
Uh-huh.
The analog or digital circuit's like, hey, I'm shooting for 1.5 volts, and then the pot moves, and it moves, and then the pot moves again. Every time it moves, it moves, and then it can never find home. So troubleshooting is a little tricky. You have to go through some elimination processes.
Servos do have a shelf life, or I should say a useful life. I mean, I've had them gears actually wear out, and some just, finally have had enough. Like Chris says, their electronics, which usually lasts for seems like hundreds of years, but tens of years. But you're in an airplane and you're doing things much tougher to electronics than a normal down to earth type of situation. So Steve, if you got new servos and they're doing that, then yeah, you've got to chase down, try each servo separately, maybe a path of it's crossing over potential noise source or something.
Actually, let me change my camera here. I want to show you what I'm working on. It might give you a better indication of what I'm talking about.
I mean, I know on gassers, you have to be really careful. In the old days, you had to be really careful about electronics noise being picked up by the engine. That kind of
So
stuff.
this is what I'm building. It's an SR-71, about 8 feet long.
Nice.
I remember
Those
seeing
are the problems. It's got long leads. It's got all sorts of stuff. So I kind of wanted to get some help with gauge wire, and some of these runs are 500-600 millimeters for some of these servos. I mean, I bought the higher gauge wire, but still having some issues.
You got good soldering skills?
Fairly good. I mean,
Yep. If you're doing that, what I've done, if I have a long run, I'll make a custom wire. I got a big
I was
roll
thinking
of
of
wire.
that.
Yep, and eliminate those connectors because that's an easy thing to get rid of.
The only problem is that the plane is so large, it splits into 4 parts. So I have to have connectors at each pod and then a
Yeah.
connector from the front to the back. So I'm kind of held to a certain amount.
So there's some better connectors we can hook you up with that we use a lot, for those hotliners that we fly where the wing comes off every time.
Yeah.
It's a more robust connector, and you would, like I said, like Buzzy said, cut off the typical 3-pin connector.
Yeah.
And the nice thing about those is there's like the typical one has 6 pins on it. So you use 2 for power ground and then the other 4 for signals. So you can run 4 servos through one connector.
Okay, so you can run one wire back and split it off.
Well, bundle, it's a bundle that you land in there, but they're much better quality connectors and they can handle plenty of current. But we can get together, Steve, and
Yeah, I'd appreciate that because I think it needs a little more in depth. And
practice RC distancing.
Would something like S-Bus help him out, like an S-Bus connection, or is that just too small for the servos he's using?
Not sure. Yeah. You're talking about running a serial connection back to everything, Kumar?
Yep, like a serial connection. Just run one serial connection from wherever to the different pods. But I'm just worried about like the voltage drop, like what we've been talking about.
Yep. So I think the first thing to do is find the problem, identify what the problem is, and go from there. But so what Kamar's talking about, like I said, today we're in the middle of the road. So there's lots of other ways of doing all this stuff. And one is you can, instead of all these dedicated PWM cables, 3-wire going to every servo, you can run things serially. And there's servos that even talk directly serial. You still need to feed them power. And you can buy servos. You can buy servos that you can program the servo itself to have a specific home point and how far it travels based on the signal coming in. And so,
yeah, I use those in my robot that I built. But the trouble is I have to use these KST servos because the only thing that fits in the wing.
yeah.
So
I'm just saying that
digital, but
I'm just saying all that to let you know, if you feel you've peaked in your part of the hobby, don't worry. The hobby is deep enough and wide enough that there's always more stuff to do and learn. So. Try flying a drone indoors, FPV, that'll keep you busy. So the only other thing I had to show you guys, which I'll share screen again. I think enough of us use electric retracts, right? So there's generally two kinds of retracts out there. Well, I should say in the electric world, there's two kinds of retracts. And they both work about the same way, where there's a long threaded rod in there, a lead screw, that pulls this little T-bar back and forth to articulate the servo. Oops. Stuck. And the two different ways they know how to move are, this one has a little circuit board down in there. And when the T-bar gets to the end, there's a little tiny switch on the circuit board. And that little T-bar on there on the threaded rod, I gotta hold this thing to stall itself out. So that little rascal hits that switch and it stops. The other kind is, there's no switches in there. And all it does is it senses that there's another circuit back here on those kind. And it senses when it gets really hard to move. So it assumes it's gotten to the end and it stops. That makes sense? So it senses the motor working really hard. Now, even the one with the switches in it has that in there. So if I tell this to move and then I hold it, it'll stop anyway. The reason I tell you that is that what happens a lot of times, and I have this happening on one of my planes, that circuit in there that senses that, hey, this thing's getting hard to work. When you're flying, if you take off and fly out and build a bunch of speed and you're going faster and faster and faster, and then you put the gear up, now you got a lot more wind resistance. That part of the circuit may sense that as, oh, I'm having trouble working, and stop. And now you're wondering why your gear only went halfway up or halfway down. And I've had changed out some of these because the circuit was a little too sensitive. And we've seen that on some other folks playing at the club, where if you're flying too fast, for instance, so this is a nose gear where it's going to come down into the wind. So if you're getting ready to land, but you're flying really fast, and you tell the gear to come down, this thing comes down, the wind's pushing against it, it may shut off prematurely and your front gear doesn't come down all the way. Yeehaw. So that's generally how gear works. Any questions on that?
I have a question as a beginner.
Yeah.
At what point do you at what point of experience do you, when you're looking around or getting a plane, like adding things like gear retracts or flaps, those are probably the two things that would be the next logical things besides what I have. How much more complicated does that make things? It seems like a gear isn't necessarily a technical flying skill ability, except you got to remember to turn it on and off, but maybe I don't know enough about it. I'm just curious.
Want me to answer, Al? You want to go for it?
Well, my answer is I flew for like 10 years without using any retracts or any flaps, and got my first plane. It had retracts, it had flaps, and like you said, it was.
We lost you, Al. We'll give him a minute, see if he comes back.
Thought it was me.
No.
No, Al's frozen.
So what Al's saying is, I think what I would say is it depends on what you want to do in the hobby.
Yeah.
So if your interest takes you in that direction, then great. If your interest takes you towards other planes that, a lot of planes you've seen at the field probably don't even have landing gear on them at all. They belly land.
You bring up a good point though, Alan, in that like retracts retracts are a feature on the plane. If you're going to have flaps and you're going to really use them, you have to understand a little bit more about aerodynamics and what you're doing flying. But when I first started, what the guy that was teaching me said, I had a trainer. This is back in the glow fuel days, and he said, fly this until you're bored, And I think I had it 2 years. It was my third year before I bought another plane. You needed to fly it until it would do anything you wanted it to do, and finally you were ready to do something more. So I don't know how many years you've been in this, yeah, but they put flaps on a lot of things, and you can put a plane in if you're not using them right.
Well, the one thing I've only done this for a year. My son and I came out and watched on one of your days in July, and we had thought about it, and I did invest in a flight simulator, which is hugely helpful, and you can experiment with the planes and put the flaps on and find out, oh, it's going to push me up, or how far down, and so that's been helpful, and a lot of those models have retracts and all that kind of stuff. So I think eventually it'll happen. I'm just kind of curious. I have a Cub, like a carbon Cub, and I put snow skis on it. I'm waiting for one thing to, my prop flew off in the middle of flying, and which was surprising. I'm not quite sure what happened, and I managed to land it without crashing and landed on the snow, and I'm waiting for a part to show up, which is annoying. But so I've been playing around with the landing just in that capacity. I don't do anything except it just doesn't have wheels. But I look at some of the planes and wonder at that point, what if there's something more to it. It seems. Yeah.
I agree with Mike. I was thinking the same thing. You've got to get to the point where you're proficient at the basics of whatever you're flying right now.
Yeah.
Or you don't have to. That's the beauty of RC. You can buy whatever you want and fly whatever you want. We don't care. And crashing is part of the hobby. It's okay.
They all die the same
I
death.
crash. Yes, they all crash. They all get destroyed. Just learn to laugh and enjoy what you had. That's all.
Yep.
Well, as some of the guys like to say, Mark, Gerard, and those guys, every plane has an expiration date on it. You just don't know what that is.
Right.
And some have rebirth dates too.
There's that moment of shock, and then you got to be laughing. And if that's not your response, you're in the wrong hobby.
Well, I was saying last week to Chris, and you guys, several of you, have all told me that. So I figured my first crash would be, right into the dirt, and it wasn't. It was a depth perception. I was flying and coming around and wanted to broaden out a little bit, and without any sense, it just went right into a tree, which I thought I was like 50 yards in, and I just didn't realize how far away I was. So my experience was not the way I thought I was going to crash. So anyway.
Oh yeah. If you're not like flying at the field, like where there's like less trees, you're going to fly into a tree. You always think you're closer or further away. It is going to happen. Like if there is a tree, your plane will find it. It's like one of those rules.
I managed to get it back though, and I fixed it, so that's good.
That's good. Any other questions? I'm watching for Al to see if he's gonna hop back on, but maybe something happens. I'll look at my notes too. Let's see. We didn't talk about motors. So let's just say this: motors. The three basic things about motors is they have a kV rating, which Al lost internet. He says. So kV of a motor, it's revolutions per minute based on applied voltage is what kV means. Now, applied voltage is a very dynamic number, but suffice it to say, if I take a 3S battery on a given motor, it spins at some RPM at max throttle. If I go to 4S, it's going to spin faster. That's the key thing, or 5S or 6S. And all motors have a limit to the voltage you can operate them at before they're going to blow up, and a wattage that you can operate them at before they blow up or damage. And all that to say that what really happens is they overheat. So again, the middle of the road answer is don't operate a motor above its voltage or wattage. The not middle of the road answer is, of course, you can operate motors at higher voltage and higher wattage. It's just how long before they blow up? But when you get to the point where you want to start building your own stuff, you're going to be asking other folks for advice on what to do and how to do it. Anything else? Are there any people, have you thought of anything that you are hoping follow-up Zooms cover? All right, we already have a list, strong list going for what we want to do, but I wanted to see it.
Yeah, I did, Chris. I assume you at some point be going over, basic transmitter setup, including things like dual rates and expo and recommendations and all that good stuff. That would be super information for me.
Okay. Yep.
Chris, I just want to add a comment. I sent you some topics right out of the gate, but then the more I thought about it, the last one I sent you, which is about just checking over your plane. We have great, because we have the winter and the summer. The winter is a great time to go through all your planes and check the hinges and check all that stuff, and just walking through and doing a standard airframe check would be a good one.
Yep. And I make it a rule that all the planes I care about get a check in April. And I do a thorough, some of them I spend hours on, I disassemble them and reassemble them because they're so complex inside there that, and sometimes I find stuff that I'm like, oh my gosh, I'm surprised it didn't crash on the last flight of last year. So I totally agree with that. Yep. As I would have covered some radio stuff today, but I felt that would have got us way too deep and long. So, because that's a whole Zoom session, I would think. Also, we probably have a wide variety of radios in use now. Kamar, what are you using?
I am currently using a Jumper T16, basically OpenTX type thing.
Okay.
So that's different from the Spectrum and the Futabas and all that other stuff.
Okay.
It's pretty similar to what I was using before, but yeah, that's another option.
So I might have to put an email out for people to respond to with if you're interested, what radio do you use, and see, if based on the interest in what radios you're using, we may have to pull in some other people to fill in the other stuff. I'm a Spectrum guy, so I can answer that stuff.
Chris, where are you buying your Lemon receivers?
Lemon
RX.
Oh, .com. They got their own site.
Yeah, I'll just Google Lemon RX. And
all right.
you should be able to find it. Yeah. If you can't find it, let me know.
I got a 10-year-old grandson. I got him real flight and bought him a starter plane for Christmas. And on Motion RC, XK makes a great little transmitter. They're inexpensive and 6-channel, and it's just perfect for what because I don't know if he's going to get into it, so I didn't want to spend a whole bunch of money, but it's great. And I also I got my own, about this little heli. Oops, you can't see it with the thing. But
Oh yeah, those are so cool. I love those.
that is very fun. That's what I've been
I
flying.
gotta pick up one of those.
And they're cheap, $125. It was amazing. And it flies inverted.
Yeah.
Is it?
Yeah, they're so cool.
This conversation makes me wonder, maybe it's on the website and I just haven't seen it or didn't remember, but having because I bought 2 of these flight test kits for my son thinking, okay, it's supposedly inexpensive, but when you buy the receiver and the thing and, all of a sudden it's not really cheap. I mean, I can crash the plane and go put that into another $25 kit and that's fine.
Yeah.
But I guess, Chris, when we talked, you were saying, oh, there's other places to get less expensive. And now, Michael, you're mentioning, is there maybe a resource page where on the website where people would, I've been trying to learn where to go.
That'd be a great idea.
Next time, so I might not spend.
Yeah, that is a pretty good idea. Alan, what you're probably running into is what you're probably running into is you're buying all of the things that you need. It's the upfront cost. You got to get the radio, you got to buy a charger and all that stuff.
Yeah.
The upfront cost is it's a little bit expensive. It's a little bit up there because of all the little things.
Yeah.
But the next flight test plane you buy, it's only going to cost you whatever the kit costs plus the electronics. You're not going to need to buy all the other things. Or if you just want to go to the dollar store and get the phone, it's super inexpensive. The parts, the electronics, they're not expensive. You don't need to buy a new radio. You don't need to buy a new charger, all that
Yeah, I
other
really,
stuff.
I was okay with that and knew, like when I bought my radio, I wanted to spend the money up front and not have to go, oh, well, you just outgrew it and now you need to go buy another
Yeah.
$400 radio, you know, but, the,
And I started in the foam board, well, Depron and foam poster board building
Yeah.
stuff. And they did used to tout it as, you know, a cheap way to build a plane. And actually, it's not that much cheaper nowadays, or really, it's not cheaper nowadays. Because by the time you buy all the power systems and everything and build the whole thing, you can buy fully ready to go planes now, foamies for less. Yeah, unfortunately.
well, it was fun to build it, you know, to have that with him is fun.
That's
And
where
he
the fun
helped me
is.
out and so knowing that, oh, if this one gets trashed, I can
Yep.
pull the parts out and spend another $25 and have another one, and you do it again.
Foam board, yes. And that's what's invaluable on the flight test, and mine was RC Powers was what I was building. The skills that you developed by scratch building a plane, literally just out of sheet of foam, are pretty valuable skills.
To test your patience sometimes too.
Oh yeah.
You got to make your own hinges. I mean, you're making hinges out of tape or, you know, foam.
Beveling them. And what's
So-
frustrating is I'm buying a plane and the video is from 7 years ago, but now the motor, it's, you know, it doesn't exactly translate. So then you're thinking, all right, you have to kind of figure it out a little bit on the
Yeah,
way.
their guides need updating.
I think a resource page of, hey, this is a place to buy an inexpensive receiver, or here's a place to get servos, or here's where you get props, or you know, that would be helpful, because I feel like I don't know, and I've been listening to a few podcasts that might be also what's helpful for podcasts, and then I hear someone mention something and I go look at their website, but I feel like I'm trying to patch together knowledge that a lot of you already know.
There is a huge, vast array of stuff out there to pick from, and what we tend to do is all summer long we're talking to each other at the field, and you know, Steve, for instance, is like, hey, I'm thinking of building this thing, you know, what do you think you should use for motors and fans and whatever. We're telling them what we think. So, you know, I'm a little hesitant to try to put up a resource page, because it's like I keep a personal spreadsheet of websites that I find, and the pages are long because I have a preference for one particular little connector that's on one website, a preference for this on another site. Pretty vast list. So Lemon RX, you saw that there, Michael?
I did. Yeah, I got it up here.
I wrote that down too.
Yeah.
They I have here oh, you can buy just the satellite itself, you know, from them. And that satellite's GSMX. It'll plug into a Spectrum receiver. It doesn't have to be.
Yeah. Nice.
But we'll go over that stuff when we do radios, Richard, because binding, you know, for instance, and all the interesting the binding stuff. And when you bind with a satellite, what happens later if the satellite stops working one day, your plane won't connect to your radio. Because the receiver goes, hey, I'm supposed to have a satellite. And so one day you're out there at the field going, why won't my plane work anymore? It's complicated sometimes.
Yeah, that's a good subject area. Binding fly type aircraft, and like I say, just the whole your philosophy on setting up the transmitter. I think I have the one that you have. The DX9 is there's a lot to learn on that. And fortunately, YouTube is there, which was the biggest help for me. Just trying to do a basic, you know, binding an aircraft and basic setup was challenging at first.
Yep. So we'll plan one of those, plus with talk about hardware setup too on a plane. I mean, again, a lot of planes people are buying are ready to go, but that doesn't necessarily mean it's set up correctly, perfectly mechanically set up correctly. So knowing how to deal with all that stuff is
Even you buy an ARF that's everything's installed, you know, when you spontaneously disassemble it at the field, you need to know how to set it up again afterwards.
Still
Mhm.
helps.
I know of a handful of new planes that are in shipment right now, so.
Oh, before you go, hey Alan, this book, I don't know if you can read that. Is it
What?
mirrored?
Yeah, I see it. 1 week to solo.
Yeah, this book really helped me, especially working with the simulator, and it's like an instructional book. It teaches you how to make turns, how to go up and down in altitude, and land and take off. Especially when you're using it with a simulator, it really helps you with the skills and whatnot when you're at the field.
Thanks. Yeah, the simulator's been super helpful.
Oh yeah.
Made a huge difference. I'm convinced I would have crashed my plane the way I envisioned crashing it much sooner, and I have yet to do that because I've practiced turning off the motor and gliding in and doing all these things, and it doesn't.
There you
You just
go.
hit the button and start over.
Yeah.
So that's been great.
And
My
Alex,
daughter actually was flying it last night, which was
Oh,
great.
nice.
I was watching her. I was like, I'm not going to say anything. If I get involved, she'll stop doing it. But she actually was curious and watched my son. And I'm like, oh man, maybe she's the one who's going to show up because he's kind of on the fence.
And she was on the sim, you mean?
Yeah, she was
Okay.
flying the Hangar 9 Cub, which is similar, you know. And I was like, okay, I don't want to say too much because if she thinks that's kind of fun, great, that'd be fun.
And is your Cub is the non-GPS type?
Which I know you are happy about. And when I bought it, I thought that's what it had. And now that I realize, and I can fly, even on the simulator, you can't go very far, and then it like turns you around, and
Yeah.
it feels like
Mhm.
you're not. And so it was I'm glad I didn't get that. And
There was at least two, maybe three people ahead of you that bought the same plane last summer, but with the GPS. And the darn thing, you barely fly, like behind Muzzy right now. You fly, a little ways away, and the darn thing does a 180 all by itself. And you're like,
right. Yeah, no, the simulator made me be able to skip all of that, and that's been good. And actually, the other thing it comes with is like a landing assist module, but it was back ordered, and it arrived months after I got the plane, so I figured out how to fly it without that anyway. And now I have
Mhm.
this thing that I'm like, well, should I put it in maybe for my son, or is that a generic thing that you could put into some other plane? I don't know if it has value for him or someone else, but
as a new flyer, as an RC flyer, in the beginning, you're just learning to dribble a basketball. And then you're going to dribble and walk and dribble and run and dribble, run, shoot. So I think what I've found is that features like help me, hit the button to help save me. You don't know yet that you're in trouble to have the wherewithal to go, oh, I got to hit the button
right.
until it's too late, usually. So the feature is nice, but it's just, as a new flyer, it's very hard to be able to say, okay, I'm in trouble, I got to hit the button.
Well, I would say anyone else who shows up to tell them spend $100 or whatever on the simulator and practice, you will save yourself the $300 on the plane guaranteed.
Yep.
And it's been super helpful. So I was comfortable enough knowing, okay, I believe that that's going to feel pretty close to the actual, and it made a big difference. So
Well, which simulator are you using?
Real Flight 9, and then it upgraded, and right after I bought it to 9.5.
Cool.
Yeah, that's basic when it comes to like my girlfriend. I brought her out to the field like last summer. I think Al got her on the buddy box, but afterwards I put her on the simulator and I walked her through it. And I did the same thing for my friend Nate. And they're like, oh, before they were like, okay, this is pretty simple, it's pretty easy. But then once they got to do it, they got to see that it's completely different. So having something like that, if it's for your friend or your kids, having them on the simulator, even having one at the field would be something useful. So people they can crash and be like, okay, this is kind of fun. This is a little difficult, but it's definitely very fun.
Cool. Any other thoughts for future Zooms?
Appreciate your time.
Thanks.
I don't have anything right now.
No problem. We got a long list, so Mike's gonna take some of them and we'll get scheduled up here soon. I think we'll just keep them rolling every Saturday for now. There's not much else to do in the winter time. Yeah, outside. Cool, man.
All right.
Well, thank you for doing it, Chris.
Yeah, thank you very much, Chris, and everybody. I appreciate all the information.
Thank you.
Awesome. Thanks, Chris.
See you guys.
Nicely done, Chris. Good.